All right, let's try this again. You're like, we didn't try it the first time. Well, yeah, you didn't, but I did. My document camera stopped recording, which was kind of obnoxious. But so anyway, I'm gonna kind of go through what I already went through on here because I assume you can't just like read my chicken scratch and understand what I meant to write here. So today, which is our last lesson of the year. There you go. We are solving radical equations. So I'm just quick reminder that when solving equations, we use reverse order of operations to get rid of things, to move them from one side to the other. So we first get rid of subtraction, addition, division, and multiplication, and then exponents, and then parentheses. And what I had said in my earlier video that you do not get to see, is that you have to treat what's inside a radical, which is called a radicand. Okay. Again, there's a little vocab for you. So treat the radicand like parentheses. So you can't, like if you have square root of x plus 4 equals 6 or whatever, you can't subtract that 4 until you get rid of the square root. So that's what I'm saying, kind of pretend like there's parentheses in there. And parentheses, when solving equations, comes last, right before it comes exponents. Exponents, the square root is an exponent. It is actually, like you could rewrite this instead of as a square root of that, you could write it to the 1/2. So a square root is something raised to the 1/2 power, which is why you square it to get rid of it, right? So because those two would cancel out, and then you just have x to the 4. So that's why when you have, like we've solved equations before where you've had x squared, and you take the square root of it to cancel it out. That's what I wrote up here, but it doesn't make sense when it's all already crossed out. So today we're going to do like the opposite of that. You have the square root of x, and we're going to square it to get rid of it. Okay. All right. So your steps here. First, we have to isolate the radical. That's an if necessary step. Sometimes you don't have anything there. Then we square both sides, and squaring both sides again gets rid of that radical. Then you get rid of anything that was in the radicand with the variable. So like going back to this little example right here, after we square both sides, we would then subtract 4. And then I put here, check your answer, problems with radicals on both sides. I'm not sure that we're going to do that. I'll kind of see where we land here. All right. So problem number 1, we have the square root of x equals 5. My first step is isolate the radical. Radical is all by itself on this side. Radical, isolate, that means just, I only have the square root. I don't have like a, 2 times this or, plus 3 on the end of the radical. So all I'm going to do then is the second step. So I'm going to square both sides. Squaring makes the square root go away. So I'm just left with x. 5 squared is 25. It is just that simple. Okay. Now I have 10 equals 2x. So I have 2 with the x underneath the radical. I don't still have anything on the outside of the radical. So this is all isolated by itself. I can go ahead and square both sides. 10 squared is 100. The square root of 2x squared is 2x. And now I just solve this. This is this part of get rid of anything that was with the radicand. So I'm going to divide both sides by 2. And I get x equals 50. Yay. Okay. Now, same thing here. I don't have anything outside of the radical, so I'm just going to square both sides. 9 squared is 81. Square root of 27x squared is 27x. So I'm going to divide both sides by 27, and I get x equals 3. All right, so those are super easy. Those are ones where you didn't have to do your first step here. We are going to move on to ones where you do have to do that first step in isolating. So here I have the square root of x, and I have a minus 4 on the outside of it. All right, so this is where it's important to get rid of things first. Because I can't, I don't want to square both sides here because then I'm going to have to, FOIL things out, like multiply binomials. We don't want to do that. So first things first, I'm going to add 4 to both sides to get rid of that. So I have the square root of x equals 9. Be careful here because 9 is a perfect square, and you're like, oh, I'm going to take the square root of it. But remember, that's not how you get rid of this. So we need to square both sides. So square root of x squared is x. Square root of 9 is 81. Easy enough, yeah? All right. So the next one, we have square root of 5x plus 1 plus 6 on the outside equals 10. All right, so here's my radical. So I need to get rid of this 6. And I have the square root of 5x plus 1 equals 4. Now I'm going to take the square root of both sides. So the square root of 5x plus 1 squared leaves 5x plus 1. 4 squared is 16. And now again, I solve this just like I would a regular two-step equation. I have a plus 1 and I have a multiply by 5. So I get rid of the 1 first. I get 5x equals 15. Divide both sides by 5. And I get x equals 3. All right, last one. Well, for this side anyway. Square root of 3x plus 7 minus 1 equals 3. So first, of course, I'll get rid of that 1. Then I have the square root of 3x plus 7 equals 4. Now what do? I square both sides. Square root of 3x plus 7 squared is 3x plus 7. 4 squared is 16. Now I'm going to subtract 7 from both sides. I get 3x equals 9. Divide by 3, and x equals 3. So as you can see, this is super, super similar to solving regular equations. You just will have to end up squaring them, okay? On these, same concept, except we don't have like an add or subtract on the end. We have a divide or multiply. So here, what is preventing the square root of x from being isolated is that it's being multiplied by 4. So first I'm going to divide by 4. So I have the square root of x equals 8. And then I'm going to square both sides, and I get x equals 64. I will tell you, I can do, when it's multiplying or dividing, I can square the whole thing without getting rid of this first, without isolating it. If there's no plus or minus anywhere outside, if it's just multiply or divide, but then you'll do a lot bigger numbers. But like, for instance, I'll just rewrite this. If I just decided right away, because it's just multiplying, that I wanted to square both sides right now, I would square 4 and get 16. I would square the square root of x and just get x, sorry. And then I'd square 32 and I get 1024. And then I take 1024 and divide it by 16, and I would get 64. So you can do it that way. I just think it's a bad habit to get into, because if there is, like, you can't do it all the time. You can only do that with multiplying or dividing, not if there is any sort of addition or subtraction happening. All right, next one, I have 6 equals the square root of x over 2. Well, this is square root of x being divided by 2. So why don't we go ahead and get rid of that divide by 2 by multiplying by 2. So 2 times 6 is 12. Square root of x over 2 times 2 is the square root of x. And now the square root of x is isolated. I can square it, and I get 144 equals x. Here I have 2/5 times square root of x equals 4. So I can do one of two things. I'll show you both. I can multiply by the reciprocal, which is 5 over 2. Then make that go away and that go away. And I get the square root of x equals 20 over 2, which is 10. And then I would square both sides, and I would get x equals 100. If you're not super comfortable with doing that, oops, that would be an x on 5, sorry, all in one fell swoop, you can certainly multiply by 5 first. So you get 2 rad x equals 20, and then divide by 2 and get rad x equals 10, and then square both sides to get x equals 100. So either way. So if you're fine with fractions, and you can see this as 2/5, and then the reciprocal is 5/2, you can do that. Okay, so there may or may not be any of these on your Delta Math. I don't remember if we put ones with two solutions on it or radicals on both sides, but just in case, let's do this. So I have rad 2x minus 1 equals rad x plus 7. So I don't have anything on either side, with the radicals. Like there's nothing being multiplied here or adding at the end or whatever. So I have my radicals isolated, so there's nothing stopping me from just squaring both sides here. So this is kind of easy because it'll make just both of those go away, and you have 2x minus 1 equals x plus 7. And now you're just solving equations with variables on both sides. So you get rid of this x, so 2x minus x is x. And then you'd add 1, and you'd get x equals 8. And then this check says you should check to make sure it works in both instances. So what that would mean is that I'm just checking it. So I'm putting 8 in for x here. So 2 times 8 is 16 minus 1 is 15. I'd put 8 in here too. 8 plus 7, that's also 15. So like those are equal, so it checks out. Sometimes what'll happen is that it'll end up as like one will be a negative, and so that's not going to be a real solution or what have you. I don't think you have any that are not real solutions. Okay. So with this one, we have rad 5x minus 4 minus rad 6 equals 0. You do not want to square this entire thing. Okay, because then again, you're multiplying binomials, and that is not cool. So what I would do is I would move this rad 6. So I have rad 5x minus 4 equals rad 6. And again, I just do what I did over here. I square both sides. And I got 5x minus 4 equals 6. Because again, remember, that just makes that go away. Add 4 to both sides. So 5x equals 10 and x equals 2. All right, and then this last one gets a little tricky because you have an x on this side and you have an x in here. So what you still have to do, so the radical, of course, is isolated on the right side. So your first step, you're just going to square both sides. So now I have x squared equals, make that go away, negative 3x minus 2. So this ends up being a quadratic equation. And so you're going to want to keep your x squared term positive. So you're going to want to move that over and that over so that you have this equal to 0 and you can solve it. So x squared, if I add 3x to both sides, would be plus 3x, and then add negative 2, so plus 2, or add positive 2, excuse me, equals 0. And now you factor, and you're like, I thought we were done with factoring. Well, kind of, for the most part. So here we have x squared plus 3x plus 2. So we're looking for what multiplies to 2 and adds to 3. Remember? So it'll look like x and x, and then whatever these two numbers are that multiply 2 and add to 3. Well, what multiplies to 2? The only thing is 2 and 1. Thankfully, that adds to 3. So we're good. And then we solve. Remember this. So x plus 2 equals 0 and x plus 1 equals 0. Subtract 2 from both sides, you get x equals negative 2. Subtract 1 from both sides, you get x equals negative 1. And again, on your Delta Math, I don't remember if there are any like this with the 2. This is where it's super important that you check your answers. So you'd want to make sure that both of these actually work in there, like in the original equation. So negative 2 equals the square root of negative 3 times negative 2 minus 2. So you'd have negative 2 equals the square root of, this is positive 6 minus 2. So that square root of 4 equals negative 2. I mean, technically, yes, because the square root of 4 equals 2 and negative 2. So that's how you check it. But I don't think that in Delta Math you have to do that. Okay, so your optional assignment here today is just solving radical equations. It's doing all these. don't get confused with 1, 2, 3. They're just giving you those first kind of few steps on the side. Like in number 3, they have rad 3x plus 5 equals 11. Then all of a sudden it's just rad 3x. Well, what did they do? Well, they subtracted 5 from 11, right? So it'd be 6. And then what do they do to get from here to here? Well, they squared both sides. So to get rid of the square root. So they would have had to square it. So 3x equals 36. And then to get from here to here, they divided by 3. So 36 divided by 3 is 12. Okay, so if that kind of confuses you, just those first 3, you might even just want to go, oh, whatever, I don't need that, and just solve it. Okay. All right. Any issues, let me know. Come on into office hours. And congratulations on making it through the very last lecture, making it through online learning. This has been an interesting experience for all of us. I hope sincerely that that these lectures have helped. I tried to, kind of do it the exact same way that I would have done it in class, just so that there was some continuity there. So my sincere hope is that you use these, to learn from. Whether you watched all of them or not, it's fine. But I did my best to keep it as Mrs. Shigley as possible. So because that's what you were used to learning from all year, or most of you were, those of you who I had all year. So anyway, that is it. And I hope you have just like the most fantastic summer, and stop by certainly in the fall if we're there, which I hope we are, and say hello. All right. Goodbye, guys.